Hello, my name is Will, and today Isaac and I will be talking to you about multi-genre natural language inference. But first of all, you may be wondering, what is natural language inference? Natural language inference is concerned with recognizing whether a sentence entails another sentence. A hypothesis is entailed by a premise if it can be inferred from it. In other words, a premise entails a hypothesis if and only if all information given in the hypothesis is given in the premise. With the central ideas of reasoning and inference proving to be a vital part of both human and artificial intelligence, researchers have continued to train inference models using neural network-based techniques. This has shown to be effective within the field of natural language inference, with scope to assess open domain natural language in order to master general natural language processing. More recently, there have been advancements in modeling inference enabled by the creation of large annotated datasets, such as the multi-genre natural language inference corpus. Now I will be handing over to Isaac, who will explain a little about the background of natural language inference.
Thank you, Will. Now, there are numerous approaches to natural language inference. One of these is using a feature-based approach. These leverage machine learning models using human contributions to represent lexical and syntactic information across the hypothesis and premise sentences. This process involves using a corpus to train the deep learning models. A corpus is a collection of text organized in datasets, containing pairs of a premise and a hypothesis. Good corpora tend to be large and contain accurate and clean data, which is well balanced to provide structure. The quality of the corpus used to train deep learning models is pivotal to drawing accurate inference conclusions. Next, Will is going to talk about the problems facing natural language inference and explain the proposed solution.
Thank you, Isaac. Now, prior to multi-genre natural language inference, there were no large, high-quality multi-genre datasets available to train machine learning models in recognizing textual entailment. The closest in similarity was the Stanford NLI corpus, which derived hypothesis sentences from image captions. However, using only that one genre of text means that there are several important linguistic phenomena that don't show up in SNLI, such as tense and timeline reasoning, or opinions and beliefs. MultiNLI was intended as an additional inference corpus that goes beyond just single scenarios. MultiNLI can provide the means for training practical natural language inference systems. The hope is that this will allow us to solve one of the major problems in the wider field of natural language processing and subsequent tasks relating to NLI, such as information retrieval, question answering, and text summarization. So what is MultiNLI and how does it work? MultiNLI is a dataset designed for the development and evaluation of machine learning models for sentence understanding. It is a collection of 433,000 pairs of premise-hypothesis sentences, with labels distinguishing the hypothesis as one that either has entailment, is contradictory, or is neutral to the premise. Because the corpus has been generated from several genres of written and spoken English, we are able to develop models to evaluate matched or in-genre and mismatched or cross-genre natural language inference problems. Among the texts used to formulate the corpus are works from the Open American National Corpus. Some of the more interesting texts that make up MultiNLI include works from the Oxford University Press, as well as reports from the 9/11 Commission concerning the events of September 11, 2001. This shows the diversity of content within the corpus. MultiNLI was designed as an extension of the existing SNLI corpus to aid machine learning efforts in question answering, dialogue, and translation. MultiNLI supports the task of natural language inference, serving both as a benchmark for evaluating representational systems for text, as well as a resource for creating natural language processing models to outperform the current state of the art. Through this training data, we can evaluate morphological analysis, syntactic parsing, word sense disambiguation, lexical semantic relatedness, and even linguistic pragmatics. This brings us a step closer to general natural language processing to read, decipher, understand, and make sense of the languages in a useful manner. This leads us on to collecting premises. The MultiNLI premise sentences are collated from a diverse range of freely available texts, which are thought to roughly represent the full range of American English. From the 10 genres of source text, we are able to construct the premise, removing any extremely short sentences which consist of fewer than 8 characters, as well as removing several types of non-narrative writing. This includes bibliographic references, mathematical formulas, and lists. Isaac will now talk about how hypotheses are collected in MultiNLI.
In MultiNLI, premise sentences are selected from pre-existing text sources. After selection, a human composes a hypothesis sentence to pair this premise sentence with. Hypotheses are collected using the judgment of 5 human Amazon Mechanical Turk workers, who will each annotate a given premise and hypothesis pair. They can label each pair as demonstrating entailment, which means the hypothesis is true whenever the premise is true, contradiction, which means the hypothesis is false whenever the premise is true, or neutral, which is where neither condition applies. These 5 votes are then taken, and a golden label is chosen based on a consensus vote. If 3 of the workers made the same annotation for a given sentence pair, that label will be selected. In 2% of cases, there are not enough votes for a golden label to be decided, and this results in a hyphen being allocated as a placeholder for the golden label. In the Stanford Natural Language Inference corpus, they encountered the problems of the annotators rushing the labeling process to make more judgments. Annotators are paid based on the number of judgments they make, so accuracy was often sacrificed in favor of speed. MultiNLI identified money as being the primary motivating factor for this, and sought to address this problem by manually allocating 1% of validation examples. For each matching judgment, annotators would be awarded an additional bonus of $1. These workers would not know which of these validation examples were manually allocated, and so it became in their best interest to make accurate judgments, as losing out on the bonuses would outweigh any extra judgments they would make by prioritizing speed instead. I will now hand over to Will to discuss MultiNLI's performance with various deep learning models.
MultiNLI maintains the advantages of SNLI, whilst improving upon the diversity of available content to better represent the use of natural English language. We will begin by looking at the current state of the art, which makes use of bidirectional encoder representations from transformers, commonly referred to as BERTs. Currently, the highest accuracy rating is achieved by the T511B model, with a rating of 92.0%. The other notable machine learning technique uses long short-term memory neural networks, which are successful in applications involving sequence prediction problems. MultiNLI achieves an accuracy of 60.0% using the bidirectional LSTM model. MultiNLI has a number of advantages. The most notable of these is the greater linguistic difficulty provided by coverage of a more diverse range of content, while still managing to be as reliable as SNLI in its labeling accuracy. Through using models to solve MultiNLI problems, we can improve upon existing applications of natural language inference in text summarization. This extends beyond simply shortening a block of text using extractive summaries, whereby parts of the original text are simply concatenated. Instead, abstractive summaries make use of the most vital information and generate natural-sounding summaries using novel words in conjunction with techniques such as paraphrasing. Together with this, we can move on to highlight some of the other advantages of MultiNLI. With the increased difficulty of the premise sentences, we can begin to train models to account for negation, intensifiers, determinators, and modifiers. This creates more resilient prediction algorithms, which can later be transferred to problems such as machine translation. Hence, MultiNLI is a key tool in developing our understanding of the full complexity of natural language understanding using machine learning models. Furthermore, MultiNLI contains a balance of entailment, neutral, and contradiction hypotheses within the sentence pairings. Moreover, testing and development sets are evenly split across the 10 genres. MultiNLI also has many genres, allowing it to be more versatile than other corpora. Hence, it should allow us to recognize a greater number of semantic features that will contribute to being able to solve machine translation problems. This training data is important. With a larger number of syntactic and lexical methods available for us to analyze, we can move away from literal translation and move towards semantic translation instead. By better understanding the meaning of the sentence, we can aim to more accurately convey the same meaning in other languages. Finally, the total volume of the text is very large compared to other high-quality corpora, such as Citel, which has only 27,000 pairs. This makes MultiNLI less prone to anomalous data, which is critical, because the involvement of humans in annotation means human error and fatigue are significant factors. And now, more from Isaac on some of the shortfalls of MultiNLI and future improvements on this corpus.
One of the most significant limitations of MultiNLI arises from the process it uses for data collection. This corpus avoids genres with content that would be too difficult for untrained annotators, which means that it has weaker support for more specialized areas. For example, technical jargon is much more commonplace in fields such as engineering and medicine. These would be considered too difficult for untrained annotators to participate in, resulting in weaker inference in these areas. In addition, the spread of volume of source text is a concern, especially when compared to its preceding corpus, SNLI. As MultiNLI's data collection process involves source text which is spread evenly across 10 genres, there's roughly 43,300 pairs per genre. This contrasts heavily with SNLI, which contains 570,000 sentence pairs for a single genre. MultiNLI also struggles with annotation artifacts, which are caused by the explicitness of words within hypotheses and the length of hypothesis sentences. The figure here containing the pointwise mutual information table demonstrates how entailed hypotheses tend to use more generic words, such as instrument or animal. Meanwhile, contradicted hypotheses contain more specific words, such as TV or cat. This is likely because generic words will cover a broader range of scenarios, whereas using explicit language makes it easy to rule out certain scenarios. Neutral hypotheses often contain modifiers or superlatives, such as favorite or many. This is because they are plausible, but not easily proven or disproven, and are hence inconclusive. The figure on the slide here demonstrates that entailed hypotheses tend to be shorter, whereas neutral hypotheses tend to be longer. Although the data for this graph came from SNLI, similar results were demonstrated for MultiNLI. Crowd workers may have created hypotheses by removing words from the premise. This would require minimal effort to increase their output, and subsequently their monetary gain. In the previous section, we talked about the use of untrained annotators causing a limitation of MultiNLI. This could easily be addressed in the future by hiring annotators who specialize in specific fields. They would be able to annotate sentence pairs within these fields, thereby strengthening the accuracy of inference in fields which involve more technical jargon, such as engineering and medicine. The cost of hiring these annotators would likely be high, but this would be a significant step in expanding the feasibility of using this corpus in a wider range of scenarios. It would also somewhat address the spread of volume of source text by enabling more premise sentences to be selected in the first place. Incorporating additional context with each premise would also help the decision-making of this corpus. For example, the table shown here demonstrates how the time, location, and weather could be used to assess 3 hypotheses with the same premise. The first hypothesis would be labelled as having entailment, as having a sandwich for lunch at 1 PM is a common occurrence, especially outside in a park when it is sunny. However, the second hypothesis would be labelled as contradiction. This is because eating dinner at 1 PM is very rare, and people eat dinner indoors more often than outdoors. Meanwhile, the third hypothesis would be labelled as neutral, because eating a sandwich meal has little impact on the likelihood of a man playing frisbee at the same time. This hypothesis would also not necessarily be more likely at 1 PM compared to another time, such as 10 AM or 5 PM. In this presentation, we've introduced MultiNLI as a large corpus consisting of 433,000 premise-hypothesis sentence pairs from 10 genres of written and spoken English, and how it was designed to address the limitations of the highly successful Stanford Natural Language Inference corpus. We have analysed the advantages of MultiNLI and how it is a versatile and reliable corpus. We've also considered the disadvantages of this corpus and how it is limited with regards to specialised topics due to using non-specialised annotators in the data collection process. While it is not perfect as a corpus, the criticisms of MultiNLI are very minor. MultiNLI meets all the criteria of a good corpus, which we explored at the start of this presentation. It's a large dataset and it contains accurate and clean data, which is well balanced across the 10 genres it covers. Therefore, we can conclude that the multi-genre natural language inference corpus is an industry-leading, state-of-the-art corpus for use in natural language inference. Thank you for listening to our presentation. We will now be open to taking any questions from the audience.